at some different ways that we are able to find the height in a parallelogram, because we know that the height always needs to make a 90-degree or a right angle with the base. So if we look at this first one, if we draw a line that goes directly from the base of this parallelogram to the top, right here, this is going to be our height because it makes a 90-degree angle, okay? So remember, the height is not always going to be one of the sides of the parallelogram. These sides are slanted, so we can't use a slanted line as our height. Like when you go to the doctor and the doctor takes your height, they say stand straight up. So this cannot be the height, this cannot be the height. So we draw in the height, and it would be right here, okay? If we look at the next one, we see our base is here. Okay, so we can look at this height. We can find this height two different ways. We could draw a line that goes directly from the top of the parallelogram down to the bottom and the base, and that would be our height right there. We can also, what we can do is we can extend out the base. So if we draw a line going from the top over here down to the bottom, we can extend the base and our right angle would be there. So while this dotted line and this dotted line are both not part of the parallelogram, we know that the base is here. So this is the plane that the base is on. And so that line is going to be the correct height. But this is not part of the base. It's just an extension so that we can identify what the height is. And that's what we're going to have to do in this last one. Because if we try to draw a line directly going down through here, we're not going to be in the parallelogram anymore. So in this one, we're going to have to extend out the base. And then we're going to draw a line going down from the top of the parallelogram. And this would be our height. So again, this will not be part of our base though. So if we said that the length of this is 3 inches, the length of our extension is 6 inches, and let's say our height is 4 inches, this is the base and this is the height. This is not part of the base. This is just an extension that we drew so that we could accurately determine the height of this parallelogram. Then we're going to go ahead and we're going to look at one more kind of problem. Number 3. In this one, it says if the area of a parallelogram is 35/42 centimeters squared, so the area is this. I'm going to write A equals 35/42 centimeters squared, and the height is 1/7 centimeter, so H equals 1/7 centimeter. Write an equation that relates the height, base, and area of the parallelogram, and then solve the equation. So this is where it comes into play, where it was important in the first one to write the formula. We know that the area of a parallelogram, area is equal to base times height, or remember we could just write it as area equals base times height. And then we're going to use our substitution here in this case. So we're going to substitute in the information that is given to us in this problem. We have the area, so we're going to substitute the area in for A. 35/42 is equal to, the base is still unknown. We still are not sure what the base is, so we're going to keep that as a variable. But we do know the height, so we're going to substitute in the height for H. 1/7. Okay. So remember, we should remember this from the warm-up, When we're solving this equation, the first thing we need to think about is how do we get the variable isolated? How do we get the variable by itself? Okay, and I know we're used to the variable being on the right side, so we could rewrite this as b times 1/7 equals 35th, 35 42nds. We didn't change the value here, we just flipped it around. And remember, to make this a 1, we have to multiply 1/7 by 7/1. So again, remembering that from the warm-up. This cancels out because remember 1/7 times 7/1 equals 7/7, which equals 1. So we're just left with b, or base. We have to keep our equation equal. So we need to also multiply the right side of the equation by 7/1. Remember, to multiply fractions, we go across the numerators and across the denominators. So we'll do 35 times 7, and we'll get 245, and 42 times 1 is 42. So we get the base is equal to 245 42nds. All right, and this can be reduced because this is, or simplified because the numerator is bigger than the denominator. So we could just think of this fraction bar as division and do 245 divided by 42. And we could see that 5 full groups of 42 go into 245. So the base is equal to 5 whole groups. And then 42 times 5 is 210. So we do 245 minus 210, and we get 35 42nds. Then if we look at this, I can see right away, okay, 35 and 42. I know that 7 goes in evenly to both of those numbers. So I can simplify that fraction. I can divide this by 7, divide this by 7. And I end up with a base of 5 wholes and 5/6 centimeters. All right, so this one was a little bit different because instead of solving for the area, we were finding the base, but we still use the same formula.